Dear students, last time we have finished a very important sum to find out the coordinates of the points which divides the given segment into four congruent parts. Now we are going to study if given points are dividing the segment AB into five congruent parts. In this question, it is very important to understand here for time being, we will not get any point as a midpoint of segment AB. That is very important. So, first of all, we have to find out coordinates of any two points by using section formula, and later on we can use the midpoint formula. So, let's see here. You will find first one that I am going to find out the coordinates of R. Now you will find coordinates of R x5 y 5. So point R point R x5 y 5 divides segment AB, divides segment AB. R divides segment AB in the ratio 3:2. In ratio 3:2. Because till point R you will find there are three parts, and after R there are two parts. So this is how R x5 y 5 divides segment AB in the ratio 3:2. Therefore, by section formula, I am going to find out value of x5. x5 is equal to mx2, x2, but this time x2 is 0, mx2 plus nx1 upon m plus n. Section formula you all know, while 5 is equal to my2 plus ny1 upon n plus n. Now simply substitute the values. x5 is equal to value of n. Value of n is 3, mx2. So 3, x2 is 0, mx2 plus nx1. So n is 2. While value of x1, value of x1 is 20, and x1 upon n plus n, you will get it as 3 plus 2, 5. While y5 is equal to ny2. So value of n is 3. So 3 ny2, y2 is 20 here. So ny2 plus ny1, n is 2. And y1 is, you will find here, 10. So ny2 plus ny1 upon m plus n. Value of n plus n we already know, which is 5. Now let's simplify here. x5 is equal to 300 plus 22 is 40 upon 5. y5 is equal to 60 plus 10 is 20 upon 5. 23 is 60 plus 10 is 20. So that will give us x5 is equal to 40 upon 5. Very simple calculation. x5 is equal to 8. Now I am going to find out value of y5 in the same way. y5 is equal to 60 plus 20 is 80 upon 5. So y5 is equal to 16. So in very simple manner, we use the section formula to get the coordinates of point R. So coordinates of point R are 8, 16. So therefore I will write it as R x5 y5 is equal to 8, 16. This is our answer number 1. So after getting R, but still you will notice one thing. R is midpoint of QS, but of course you will find, or R is even midpoint of PB. That's fine. Here you will find 2 parts this side as well as 2 parts this side. So here you can surely use midpoint formula, but let's see that for one more point, at least for S, or S is quite simpler than this. Okay, so here we know the coordinates of R, so we can find out the coordinates of S by using midpoint formula. So let's see here how to find out the coordinates of S is x6 y6 is x6 y6. So x6 is equal to x5 plus x2, x5 plus x2 upon 2, and y6 is equal to y5 plus y2 upon 2. Please look here once again. S is a midpoint of BR. Therefore, you will find x5 plus x2 upon 2. We know the coordinates of R, which are x5, y5. We also know the coordinates of B, which are x2, y2. Therefore, you will get here x6 is equal to. Now, coordinates of x5 are 8. So, 8 plus 0 upon 2. y6 is equal to y5. y5 is 16. So 16 plus 20. 16 plus 20 upon 2. So I'll do the calculations on left hand side. Please see here, this is a segment which is divided into 5 congruent parts. So far we got the coordinates of R. Now I am trying to get the coordinates of all these points. I find out the coordinates of R by using section formula. Now I will find out the coordinates of remaining points by using midpoint formula. So x6, I am going to continue here. x6 is equal to, now 8 plus 0 is 8 only upon 2, while y6 is equal to 60 plus 20, that will give us 36 upon 2. So therefore x6 is equal to 2 4s are 8. In the same manner, y6 is equal to 18. Therefore coordinates of S which are x6, y6 are nothing but 4, 18. So this is how we can get the coordinates of S also, which are x6, y6 as 4, 18. Now our problem is to get the coordinates of Q as well as P. Now you will find R is the midpoint of QS. Try to understand this. R is midpoint of QS. We know the coordinates of R we know the coordinates of S. Out of these three, if we know the coordinates of any 2 points, we can surely get the coordinates of the remaining point. So I am going to now find out coordinates of, so here you will find by using midpoint formula only in all these cases. Only for one point I use section formula. Again I am explaining you the same fact that R is a midpoint of QS. So here, third one, R is midpoint of QS. Now see here, dear students, x5 is a midpoint, okay? So x5 is equal to x4 plus x6. x5 is equal to x4 plus x6 upon 2. So x5 is equal to x4 plus x6 upon 2. In the same manner, y5 is equal to y4 plus y6 upon 2. I am using their midpoint formula. Now I substitute the values. I know the value of x5 as 8. So 8 is equal to value of x4 is not known. So x4 plus value of x6. x6 is 4 upon 2. So in very simple manner we can do this calculation. If I transfer these two to the left hand side, I will get it as 16 is equal to x4 plus 4. Please try to understand. 2 8s are 16 is equal to right hand side is x4 plus 4. In the same manner, y5. Now we also know the value of y5. y5 is 16. So 16 is equal to y5 is equal to 16. So 16 is equal to y4. Okay, y4 we have to find out. y4 plus y6. We'll see the value of y6 is 18. Fine. 18 upon 2. So 16 2s are 32. That is equal to y4 plus 18. Now very simple calculations are left out over there, but for our convenience I'll write the coordinates of R here, x5 y5, x5 y5 as 8 comma 16. 8 comma 16. This is first one which we got. So later on I'll write the answers of all these points. So let's solve it now. Further we will find using midpoint formula for all these points. Even you can use section formulas. 16 minus 4, that is equal to x4. So you will find 12 is equal to x4. Got it? The value of x4 as 12. In the same manner, 32 minus 18, that is equal to y4. So y4 is equal to 14. So this is how we will get third point R. Coordinates of R are x4, y4. We got them as 12, comma 14. R x4 y4 is 12, comma 14. Now only one point is left out, and it is very simple because you will notice that is point P. The second point which we got is S. X6, Y6. Coordinates of X6, Y6 are 4, 18. And third one we got Rx4, Y4. Rx4, Y4. That is equal to 12, 14. 12, 14. So next to that we will find, I am going to find out x3, y3. But you will notice very important thing or very easily that P is the midpoint. So let's see here. P x3, y3 is a midpoint of again you see here P x3, y3 is midpoint of AQ. Okay, so very simple way. x3 is equal to x1 plus x4. x1 plus x4 upon 2. While that of y3 is equal to y1 plus y4. y1 plus y4 upon 2. Simply substitute the values and get the answer. So x3 is equal to x1 is 20 plus x4 is 12 upon 2, while that of y3 is equal to y1 plus y4, that is 10 plus 14. 10 plus 14 upon 2. So that will give us very simple calculations next also. Next calculations are also very simple. That we simply have to add and divide them by 2. So please see here for the next calculations. x3 is equal to 32. x3 is equal to 32 upon 2, while y3 is equal to 10 plus 14, 24 upon 2. So x3 is equal to 16, while y3 is equal to 12. So you will find here coordinates of point P, which is a midpoint of AQ, are 16, 12. So we can say that P x3, y3 is equal to 16, 12. So fourth one, P x3, y3 is equal to 16, 12. So this is how you will find it is very big sum. The given segment is divided into 5 component parts, and if it is divided into 5 component parts, it is not so simple to find out the coordinates of this P, Q, R, S. You know, there are 6 coordinates are there, including A and B. So this question will surely carry 4 marks. So please see that for only one point I use section formula, and later on I use midpoint formulas for all of them. If we know sometimes midpoint, then you will surely find we can find out the coordinates of the extreme points also. Now coming to the next point, next topic of this chapter is slopes of the lines. Very important. Slopes of the lines in xy plane. I repeat again, slopes of the lines in xy plane. Xy plane, as you all know, in coordinate geometry, we use x and y axis, and then we get, for example, you will find if I draw, this is y axis, this is x axis. So if I label it as x, this as y, y dash, x dash. Okay. Now you will find here, if I draw any line, supposing if I draw this line L. Now this line L has given an angle of theta with respect to x axis, and if I am having the points as P, x1, y1, Q, x squared. Right? Whenever any line makes an acute angle with respect to the x axis, okay, then you will get slope of line PQ is equal to y2 minus y1 upon x2 minus x1. And slope of this line will be positive, reason being that angle theta is an acute angle. So slope of line PQ is equal to y2 minus y1 upon x2 minus x1. Now, if I draw again x axis, this is x axis, y axis, this is origin as you know, x dash, y dash. This time you will find this angle theta is an obtuse angle. Very important to note. This is obtuse angle. Right? Then you will find, if I take points on this, x2, x1, y1, q as x2, y2. In this case, in the first case, this is acute angle. This is obtuse angle. Slope is positive. Slope is positive. Then here also you will find it is obtuse angle. Therefore, slope is negative. Formula is same. Formula is same. So slope, for example, if I call it as n, slope of line n, slope of line n is equal to same thing, y2 minus y1 upon x2 minus x1. This is formula. But in this case, you will find slope is negative because the angle formed by line with respect to the x-axis is an obtuse angle, and therefore you will be getting slope of line m y2 minus y1 upon x2 minus x1, but slope is negative. Now next term, slope is very interesting one also. Slope is always denoted by m. So slope m is equal to tan theta. There is no need to prove it how it comes tan theta. Only for your level you have to remember that slope is always denoted by m, and that is equal to tan theta. Now, very important points to remember. So, slope of lines parallel to x-axis or slope of x-axis is 0. Second point, slope of lines parallel to x-axis or slope of x-axis itself is 0. Then slope of lines parallel to y-axis, slope of lines parallel to y-axis or slope of y-axis is not defined. Very important. Is not defined. So these two things you have to remember, that slope of lines parallel to x-axis or slope of x-axis itself is 0, and slope of lines parallel to y-axis or slope of y-axis is not defined. Now, two more points are very important. Those 2 points are third and fourth. We are going to even use in our sums also. So please see here the point number 3 to remember. Please note this point. The slope of x-axis or all the lines parallel to x-axis, their slope is 0. Third point. If two lines are parallel to each other, their slopes are always same. Their slopes are always same. If two lines are parallel to each other, their slopes are always same. For example, if I say m1 has a slope of first line and m2 has a slope of second line, then I'll get it as m1 is equal to m2. Fourth point, actually this point is not given in your textbook, but this is also a very interesting point. If two lines are perpendicular to each other, product of their slopes is equal to -1. Supposing m1 and m2 are the slopes of two lines, then you will find m1 into m2 is equal to -1. So this is how you will find students to remember these points, that slope formula is y2 minus y1 upon x2 minus x1, while that of slope is also in the angular form. slope n is equal to tan theta, slope of lines parallel to x-axis or slope of x-axis is 0. Slope of lines parallel to y-axis or slope of y-axis is not defined. The next to that third point is, if two lines are parallel to each other, their slopes are always same, so n1 is equal to n2. If two lines are perpendicular to each other, product of their slopes is -1, so n1 into n2 as -1. So these all points we have to remember while solving the next exercise. That is our exercise number. We'll find 5.3. So I'm going to begin now. Exercise 5.3. But please remember this all points carefully. In exercise 5.3, you will find so 5.3, angles made by the line in the positive direction of x-axis are given. Find the slope of these lines. So please have attention over here. These are important points. You have to read these points again and again. All these points, that slope formula, y2 minus y1 upon x2 minus x2, as well as slope is given by the formula. Okay. So 5.3. Angles are given. Question 1. Angles are given. Angles are given. Find out slopes of lines. So let's see here. Angles are given as first of all. First one is 45 degree, second one is 60 degree, and third one is 90. So you must know the values of. Okay. So you will find that tan 45 answer. We have studied here. Slope is also, right? Slope is also equal to the angle made by, okay, made by line in the positive direction of x-axis. So first one, theta is equal. So here you will find that slope m is equal to, right? Slope m is equal to tan 45. So tan 45 is 1. So your answer is 1. Second one is theta is equal to 60. So slope m is equal to tan 60. Tan 60 is √3. Then next to that is third one. That third one is tan 90. It is very important. So third one is theta is equal to 90. M is equal to tan 90. Cannot be determined. Cannot be determined. So very simple, you must know the values of tan angles, what is tan 30, tan 45, tan 60, tan 90, and so on. So these are in very simple manner we find out the answers of this too. Now next to that, find those slopes of the lines passing through the given points. Okay, this is our question number 2. I repeat this question again. Find the slopes of the lines passing through the given points. So first one is A. Coordinates of A are 2, 3. Coordinates of A are 2, 3. While that of coordinates of B are 4, 7. 4, 7. Label them as x1, y1, x2, y2. So slope of AB. So slope of AB is equal to slope of AB is equal to n. That is equal to y2 minus y1. Very simple. Upon x2 minus x1. So that will be y2 minus y1. So y2 is 7, 7 minus 3 upon x2 minus x2, that is 4 minus 2. 7 minus 3 on 4 upon 2. Therefore, n is equal to 2 2s are 4. Very simple sums, very mechanical sums. You simply have to remember that slope of line formula is y2 minus y1 upon x2 minus x1. Question number 2, sum number 2. So question 2, sum number 2. In this case, they have given us P minus 3, 1. P minus 3, 1. While Q 5, minus 2. Q 5, minus 2. Same way, label them as x1, y1. This second point as x2, y2. So slope of line PQ. Slope of line PQ is equal to same formula y2 minus y1 upon x2 minus x1. y2 minus y1 upon x2 minus x1. That is equal to y2 is minus 2 minus y1 is 1 upon x2 minus x1. 5, be careful here, minus x1 minus 2 minus 3. So next step is minus 3 upon 5 minus makes it plus. So 5 plus 3, that is minus 3 upon 8. So slope of line PQ, slope of line PQ is equal to minus 3 upon 8. These all are, as I told you, very simple sums are these ones. Less possibility of having any mistakes over here. So you will find that the first one, the second one is minus 3 upon 8. Now let's do the third one. Third one is C5, minus 2. Question number 2, sub question 3. So you will find here third one, question 2, sub question 3. In third one, coordinates of C are 5, minus 2. Coordinates of C are 5, minus 2, while that of coordinates of D are 7, 3. D are 7, 3. Same way, labels coordinates of C as x1, y1, coordinates of D as x2, y2. Very simple way. So later on, you will find by slope formula. So slope of CD is equal to slope of CD is equal to same formula y2 minus y1 upon x2 minus x1. So y2 minus y1 upon x2 minus x1. Simply substitute the values again. So value of y2 is 3 minus of minus y1, that is minus 2, upon x2 minus x1. x2 is 7 minus 5. That is equal to 3 plus 2 upon 7 minus 5 is 2. Try to understand here. y2 minus y1, that is 3 minus of minus 2. That will give us 3 plus 2. x2 minus x1, 7 minus 5. So 5 upon 2. This is slope of line CD. So slope of CD is equal to 5 upon 2. One more sum is there, I think. Okay, you know 6 sums are there. So next to that is fourth of question 2. These all are again, I am telling you, very simple sums. They carry 2 marks only. So you will find the next one is question 2, fourth one. L. Coordinates of L are given as minus 2 comma minus 3. Minus 2 comma minus 3. While that of coordinates of M are minus 6 comma minus 8. All these are same sums, same formula, no difference at all. x1, y1, x2, y2. Same type of sums, these all. So again, let's say slope of line LN, or LN simply you can say, is equal to y2 minus y1 upon x2 minus x1. Substitute the values, y2 minus y1. So y2 is minus 8 minus y1, that is minus of minus 3, while x2 is minus 6 minus 6 minus of minus 2. See here, yes, is minus 2. So minus 8 plus 3 upon minus 6 plus 2. I give the effect of minus sign over here. So minus 8 plus 3, naturally you find minus 5. Minus 6 plus 2 is minus 4. Minus sign will get cancelled from numerator and denominator. You will get slope of Ln. Slope of Ln is 5 upon 4. This is fourth question. Okay. This is fourth question of question number 2. Now see here, I am going to do fifth question. I am going to do now fifth question. Now fifth question is sub question of 2. Fifth one. The given coordinates of E. Coordinates of E are minus 4, minus 2. Coordinates of E are minus 4, minus 2, while that of coordinates of F are 6, 3. Coordinates of F are 6, 3. Same way, label the coordinates of E as x1, y1, while that of coordinates of F as x2, y2. Now, slope of EF, slope of EF, that is equal to y2 minus y1 upon x2 minus x1. Slope of EF, same formula, y2 minus y1 upon upon x2 minus x1. y2 is 3. y2 is 3 minus value of y is minus 2. While that of x2 is 6. So x2 minus of minus 4. y2 minus y1, that is 3 minus of minus 2. x2, that is 6 minus of minus 4. So you will get here next 3 plus 2 minus effect of minus sign on minus 2. 6 plus 4. 6 plus 4. 3 plus 2 is 5 upon 10. So naturally it is 1 upon 2. Slope of EF. Slope of EF as 1 upon 2. All these sums are of same type. So 6 of question number 2. 6 of question number 2. 6th of question number 2. Now in 6th one you will find points given are t0 comma minus 3, t0 comma minus 3. This is the first point, and second point s0 comma 4, s0 comma 4. As usual, till sum number 5 we have taken the coordinates of first one as x1 y1, while that of coordinates of second one we have taken them as x2 y2. We always label the coordinates of first point as x1 y1, while the coordinates of second one as x2 y2. So slope of TS, slope of TS is equal to, formula is same, y2 minus y1 upon x2 minus x1. So value of y2 is 4, while that of value of y1 is minus 3. Be careful here, minus of minus 3. x2 minus x1, that is 0 minus 0. So you will find here 4 plus 3 is 7, 7 upon 0. Here you must mention, answer is very important, that in this case you have to mention it is as this one, slope cannot be determined, very important. Slope cannot be determined. Why this is so? Because whenever denominator of any number is 0, in that case you always mention that we cannot find out or we cannot determine the value of that number. So this is how you will find we have finished here. Question number 2. You know there are 6 questions in this question number 2. So all these questions I have solved very mechanical systems. Every time you have to label the first point as x1 y1, while that of second point as x2 y2. And slope formula is y2 minus y1 upon x2 minus x1. This is how we finish here. Question number 2. I'll continue the next question in the next lecture, that is lecture number 17. Okay, my next lecture will be lecture number 17. That time I'll explain you that we have to decide whether given points are collinear or not by finding out their slopes. Thank you.